All right, so I'm looking at question number 1 here in the upper left. This one right here. And what it tells me is I've got a storage tank that's vented to atmosphere, right? And here's atmospheric pressure up here. And it tells me that I have 100,000 gallons. And it tells me the temperature of this water is 80 degrees Fahrenheit. And I have a gauge at the bottom of the pressure, of the tank rather. It says 5.6 PSIG gauge pressure. It's reading 5.6. It wants to know what the level is. What is level if that was exerting 5.6 pounds? Well, here's something you need to know. You can look in the for equation sheets using gravitational constants and gravity. However, here's a simple formula. Pressure being exerted is equal to density of the fluid times height divided by 144, where that height is in feet. Let's prove this is true. So pressure equals density. The unit for density, if you'll recall from earlier in the chapter, is pounds mass per cubic feet. Up here, height is in feet, and we divided by 144 because there are 144 inches squared in a foot squared. So you can see 1, 2, 3, those cancel out with those 3 cubic foot, and I have pounds mass per inch squared, where 1 pound mass is equivalent to 1 pound force. So I can convert this to pounds force per inch squared. So having said that, I know this, it's 5.6. I'm trying to solve for height. What I need to know is, can I figure out the density of this water? And if I can, then I'm just going to solve this at like this. Pressure. Oops, I'm off the chart here. I'm going to solve this up here. Pressure, which I know, times 144 divided by density is going to equal the height. And I've just solved this equation for height. Another way, if I know that density is equal to 1 divided by specific volume, I could substitute this in there. So if I put 1 divided by specific volume here, well, I can get rid of both of those, and I can just go specific volume right there, times pressure times 144. Now, what that requires us to do is go to this book, which we haven't learned yet. So we're going to learn this book in chapter 3. But what you'll see here is when we open this book, Properties of Steam and Water, these are steam tables. And you'll see that here's the temperature and pressure. And then you're going to have 3 columns of specific volume, and then 3 columns of specific enthalpy, and then 3 columns of specific entropy, and then pressure again. So you can see that that's just to help us out. Well, we come over here, and I'm going to look at the temperature. And it says it's 80 degrees. And if you're looking, just go right on down until you find 80 degrees. And I see that 80-degree water right there has a volume of, and I have 3 columns here. I have V sub F, V sub FG, and V sub G. In this case, and we haven't gone over this yet, but we're fixing to here, chapter 3. In this case, I'm going to go to the V sub F column because it's a subcooled liquid. I'm going to go to V sub F, and I see that I get a specific volume of 0.016074. So I've got 0.016074 cubic feet per pound mass. That took care of that. Now let me put this in here. I've got the pressure, which is reading 5.6 pounds force per square inch. I know that there are 144 inches squared in a foot squared. And let's see what we've got. Let's see, I've got 2 feet here. And, oh, that only gives me 1 foot there that I can get rid of 2 of those. At least 1 pound mass is 1 pound force, inch squared, inch squared. Hey, my units are going to be in feet if I solve this. Let's see what that works out to be. So we're going to grab our handy dandy calculator, and we are going to multiply. And I am multiplying 0.016074 times 5.6 times 144, and I get 12.96 feet. When I do this, I get 12.96 feet. So when you're looking, my options are 13 feet, 17 feet, 21 feet, 25 feet. I think we'll pick alpha, 13 feet. Key part, don't forget, pressure equals density times height divided by 144. If you know pressure, you can solve for height. Pressure equals density times height divided by 144, or pressure equals height divided by specific volume times 144, because density equals 1 divided by specific volume. Very easy equations to know and understand. You know that if you want to maintain a constant pressure, as density is going up, height would have to come down. So these are really, really useful equations.